So let us look at partial fractions where the denominator is repeating or is raised to a power more than 1. Okay, so the rule is very simple. So if you look at this example that I've given you here, you've got ax plus b squared. So it's repeating itself twice. So when that be the case, when you decompose this partial fraction, the first one is going to be ax plus b to the power of 1. Then the second one is going to be b over ax plus b to the power of 2. Now, just right here, I can say we can extend this to any power that we want. So if it was to the power of 3, the first one would have been power 1, the second one power 2, and the third one power 3. Now, quickly, let us look at the examples that did show up in some previous examples, exam questions that came. So there is a question here where we are given 3x plus 8 over x plus 1 squared being equivalent to, they even give us x plus 1 and then x squared, x plus 1 squared. So if that be the case, remember we should just, they've already given us these decompositions here. We must always remember this multiplies that and that multiplies that. So I'm going to write it up top here. When a multiplies this, it's going to be, first we write 3 plus 8 being equal to a multiplying the second denominator, x plus 1 squared, plus b multiplying the first part, which is x plus 1. Now, if you look at this case from what we did on the first part of partial fractions, where we have linear factors, we've got x here, we've got x on the right. We must choose numbers that we can replace there depending on what we feel would make this equation easier. So for me here, the first one, I'm going to choose x being equal to 0. So when x is equal to 0, this is going to be 3 times 0, okay, plus 8 being equal to, if I put 0 there, I'm having 1. 0 plus 1 is 1. 1 squared is simply 1 times a. I'm getting a. If I put 0 there, I'm going to have 0 plus 1, 1. Then b times 1 plus b here. Okay, so 3 times 0 gives me 0, which means I've got a plus b equals to 8. This is my number 1 equation. Okay, then I'm going to say let x be equal to 1. So we can say let x be equal to 1. When x is equal to 1, I'm going to write it over here. It's going to be 3 times 1 plus 8 being equal to, if I put 1 here, I'm going to have 1 plus 1, 2, squared, 4. So it's going to be 4a plus. If I put 1 here, it's going to be 1 plus 1, 2 times b, 2b. Okay. So now, if this be the case, we are going to have 3 times 1, 3 plus 8, 11. So we have a second equation of 4a plus 2b equals to 11. And remember, our duty is to find the values of a and b. So what we are going to do here is simply to solve this and find the values of, find the values of a and b. So right away we know we are going to multiply this by 2 so that I can eliminate the b, which then would give me 2a plus 2b equals to 16. Then I've got 4a plus 2b equals to 11. I will subtract these two like that. 16 minus 11 is 5. That would cancel. Then 2 minus 4 gives me negative 2a. Then I divide by 2. I divide by negative 2. Negative 2 to mean a is equal to negative 5 over 2. We keep this. Then after doing that, we are then going to replace this value of a into the first equation to mean negative 5 over 2 plus b equals to 8. So I can transpose this guy to mean b is equal to 8 over 1 plus 5 over 2. So we can then simplify this to mean, because I'm not using a calculator, so 8 can be written as 16 over 2 plus 5 over 2, to imply that b is simply equal to 16 plus 5 to give me 21 over 2. So these are the values of a and b. And after we do that, it's very simple and basic. So we are going to put where there is a, we put these. So a is negative 5 over 2. So meaning, if I replace it there, I'm going to have negative 5 over 2. Then this is over x plus 1. Plus b, which is 21 over 2 over x plus 1, but everything squared. Now, I told you how to flip these. Just flip them as they are, because this does not look nice. You can then say this is negative 5 multiplying, this is negative 5. So that is going to be negative 5 over 2 x plus 1, okay, plus 21 over x plus 1 squared 2. So this is our answer to the question. So very important things where when we chose numbers to kill the x, we must be able to kill x so that we avoid. So you can choose any numbers, but the number that you replace on the left must be the same number you replace for x on the left hand side, and then you just solve your simultaneous equations. This way is much easier than the comparison of coefficients. So let us look at another example on partial. Look at this one here. So you can see here at the base is x power 3, at the top is x power 2. So we don't need to look at the order of these two expressions. So we're just going to decompose this. So the first one is going to be a over x plus, then this is a repeating denominator here, so it's going to be b over x plus 2. Then the third one, which is c, is going to be, as we said, x plus 2 squared. This is how it's going to be, x plus 2 squared. So we have that there. So now the rule is very simple. Remember, when we had two things, we were multiplying this by that. Now in this case, a is going to multiply this and that together. Okay, so what we are normally doing is b is going to multiply. So in this case, if you are getting confused, it's important to try and see them in the form of what's the highest common factor. So you are going to do this. You draw this to mean x, then you have x plus 2 squared. So if you want to know what to multiply a, you say x into this, you cover this guy. It means when you get a into this, you are going to multiply a by x squared. So it means you've got a, then x plus 2 squared. Then for b, if you have one of this into there, okay, one of it is going to cancel out. So you're going to have b multiplying these two here. X plus 2 squared Then for b, you are going to say this thing into there means you are going to multiply it by x plus 2. Okay. And then when c goes into this whole thing will go out. You are going to remain with x. So it means you are going to have a situation of c multiplying x. Okay. So basically what we are doing is for a, we are going to multiply a by that or that if they are different, but in this case they are the same. So a means multiplies that. So you just use common denominator. You cancel out the a, you multiply by what is left for a. So it then simply means 5x squared plus 10x plus 8. okay, is equal to a x plus 2 squared plus b. Now in this case, I'm going to take the x inside to have x squared plus 2x and then plus c, which is times in x. Now when we get here, it's very easy to find the a, the b, and the c because we've got x's on all the sides. So I'm going to choose x that will make this guy 0, okay? So this x that I'm going to choose is simply going to be equal to x equals to 0. So when I choose x equals to 0, it means this is going to go to 0 and that is going to go to 0. Then I'll find what my value of a is. So it means this is going to be 5 power 0 squared plus 10 0 plus 8 equals to, when I put 0 there, I'm getting 0 plus 2, which is 2 squared 4. So I'm getting 4a. Without wasting time, since all these are x's, these will go to 0. So there won't be anything. So these will be 0. And it means my 4a is equal to 8, implying that a is equal to 2. So I've found my a. I now look for other values of x to help me find my b and c. So if we do that now, we are going to work to find a situation where we make this be equal to 0. Okay, so we're going to replace the value of x with the a to give us 0. This should be negative 2. So I'll say when x is negative 2, it means this is going to go to 0 because it will be negative 2 plus 2, 0. So this a is going to disappear, but my right hand side is going to remain with b multiplying negative 2 squared plus 2 times negative 2, okay, minus 2c. Now this whole thing is going to be equal to this guy. Negative 2 is 4. This is negative 20. You can do that in your own good time. And then this gives me negative 12 plus 4 to give me negative 8. So this should be equal to negative 8. You can confirm that in your own free time. Then this gives me 4. I get 4 minus 4. It means b would now be 0 as well because this inside is going to be 0. And it implies that negative 2c is equal to negative 8, which implies c is equal to 2. So we've found what a and c are. So what we then just need to do is to find b. So we can find another guy that we can do. How do we find b? So let's see how we find b. Okay, so now to find b, since we've got c and we do have our a, we just need to substitute in our equation, which is this one here that we wrote here. Okay, so I'm just going to write it in a very on a separate space. Maybe let me take off something here. I'm going to take off everything here. I'm hoping you did copy what you needed to copy. Okay, so we'll take off this space here. I will leave out the answers for C and A. So we want to find B. Now to find B, it's very easy. So we already have our A and C. So what we are then just going to do is to replace those values in there. So we've got 5x squared plus 10x plus 8 equals to, our A is 2. So we've got 2 x plus 2 squared plus b, which is x squared plus 2x. Remember I expanded that, and then plus our 2x. Now to find the value of b, we can choose any value of x to replace for x, and then just simplify and solve by equating the equation. So in this case, we are going to say let x be equal to 1. Okay, so when we let x be equal to 1, okay, what we are then going to have in this situation is replace x equals to 1 on the right hand side. So you have 5, you are going to have 5 times 1 squared, which is 5. So you have 5 times 1 squared plus 10 times 1 plus 8. Okay, so this gives us 10, 18, 18 plus 5 gives us 23. So we've got 23 onto the left hand side. 1 plus 2 here gives us 3. 3 squared gives us 9. 9 times 2 gives us 18 plus. Then in this bracket here, if x is 1, 1 squared is 1 plus 2 times 1, which is 3. So we've got 3b here, and then here we just have 2. Okay, so we just solving for b here. We get 23 equals to 18 plus 2 plus 3b. Okay, we can solve this to give us 20, then transpose here to give us 23 minus 20, which gives us 3b equals to 23 minus 20, which should give us 3b being equal to 3. We divide by 3, we divide by 3 to then find that our b is equal to 1. Okay, so if we found our c and our b, all we are doing now is to replace these guys and put them here. So we're going to take out our usual b's there and a's. All we are doing is our a was found to be equal to 2, so we put 2 there. Our b is 1 and our c is 2. So that's what we need to do. So you need to go through this example. It's a very nice one, and take your time to just work through all the steps. Otherwise, thank you very much for this segment of partial fractions where the denominator is repeating. You can practice more examples in your own free time. Thank you.